The thermostatic operation of the Velan steam trap brings a number of advantages to plant personnel. Chief among these is a complete resistance to plugging and freezing. The location of the ball valve on the downstream side of the orifice has two major advantages. First of all, when condensate temperatures at the trap drop below saturated steam temperature, the bimetals relax and the valve is forced open by the line pressure. This ensures that the failure mode of the Velan steam trap is always in the open position, preventing freezing, waterlogging, and damage to piping and process equipment. Secondly, the downstream valve design prevents clogging of the orifice due to copper oxides or iron oxides present in the condensate. Most conventional steam trap designs locate the valve on the inlet side of the orifice. This is true for inverted bucket, thermostatic capsule, thermodynamic, and float-style steam traps. When copper oxides are present in the condensate, they build a deposit at the point in the system where the condensate flashes to steam due to pressure drop. In the case of conventional upstream valve designs, this flashing occurs inside of the trap orifice, eventually restricting and blocking condensate flow and resulting in the freezing or plugging of the equipment being drained. The Velan steam trap, with a downstream valve design, produces condensate flashing after it has passed through the orifice, leaving any hard mineral deposits on the outside of the ball valve and not inside of the orifice. Our field experience over 6 decades demonstrates that facilities that experience a high incidence of steam trap plugging due to copper oxides can reduce or eliminate this problem by changing to the Velan design.